Hey, have you ever wondered about how the web browser works? Well, they are a part of our daily life, but we rarely think about what's happening behind the scene. In this video, we'll explore the magic that goes on under the hood of a web browser. Why am I explaining this? Because as a hacker, you need to learn about how a browser works, and only then you would be able to be a great bug bounty hunter and find bugs in websites. So in order to understand, let's begin how the browser works. Well, the first step in loading a page is navigation, which happens when you enter a URL in the address bar or click on a link. Let's break down the navigation a bit further to understand it more. To start with, the browser needs your IP address, through which it would find out where the resources for the web page are located. And that is done using DNS lookup. Essentially, DNS is a server that matches a website hostname to their corresponding IP addresses. The DNS server contains a database of public IP addresses and their corresponding domain names. So when you visit www.example.com, the DNS server will return IP address 93.184.26, something like that, which corresponds to the website. The next step is to establish a TCP connection with the server. This is done by a three-way TCP handshake. First, the client, in our case, which is our browser, sends a request to open up a connection to the server with a SYN packet. Then the server responds with a SYN-ACK packet to acknowledge the request and request the client to open up a connection. Finally, the client sends an ACK packet to the server acknowledging the request. If the website uses HTTPS, the next step is to establish a TLS connection via a TLS handshake. During this step, more messages are exchanged between the browser and the server to ensure secure connection. First, the browser sends the server a message that includes a TLS version and a chip or suit it supports, as well as a string of random bytes known as client random. Then the server sends a message back containing the server SSL certificate, the server chosen chip or suit, and the server random. The browser then verifies the server SSL certificate with the certificate authority that issued it to ensure that the server is who it says it is. The browser then sends a pre-master secret, which is encrypted with a public key taken from the SSL certificate from the server. The server then decrypts the pre-master secret, and the browser and the server generates a session key from the client random, the server random, and the pre-master secret. Once the TCP connection is established between your browser and the server, your browser can now start fetching resources from the server. If you have some experience in hacking, you have probably heard of HTTP requests. HTTP requests are basically used to fetch resources from the server. To process a request, you need to provide URL and the type of request you want to make. Suppose get, post, port, delete. In addition to that, your browser also adds some extra headers to the request to give some more context. Usually, the first request that is sent to a server is a GET request to fetch an HTML file, and then the server responds with appropriate HTTP response that contains a status code header and the body. When a web page is loaded, the first thing the browser does is to tokenize the HTML file. Tokenization is the process of breaking down the HTML file into meaningful chunks, which are called tokens. These tokens are the basic building blocks of a document object model, which is also called DOM tree, which is a tree data structure that represents the nodes in HTML document. The next step is to convert the sequence of token into a tree structure using a process called lexing. The process creates DOM tree, which is used by the browser to display the web page. Now, if a web page requires any external resources such as images, scripts, or CSS files, the browser handles them differently. Non-blocking resources are fetched in parallel, meaning that they are downloaded simultaneously without blocking each other. Deferred resources are also fetched in parallel but are executed after the DOM tree is constructed. Example of deferred resources are script with deferred attributes and CSS files with deferred attribute. Finally, blocking resources such as scripts without deferred attribute are fetched and executed sequentially one after the other. Alright, so once the browser has constructed the DOM tree for the web page, it moves on to generating the CSS object model. To do this, the browser parses the CSS file associated with the web page and generate a CSS object model. This process is similar to the one used to construct the DOM tree. where the CSS file is tokenized and parsed to generate the CSS object model. The CSS object model is essentially a tree data structure that represents the style applied to various elements on the web page. With both the DOM tree and the CSS object model generated, the browser can now process the next step of rendering the web page, which involves applying the style from the CSS object model to the appropriate element in the DOM tree. Now, as I mentioned earlier, if a page requires a script that needs to be executed immediately, and if it is blocking script, it will fetch and execute it without waiting for the DOM tree. However, if it is a non-blocking script, it will be fetched and executed after the DOM tree is constructed and finished. No matter when the script is executed, it will be handled by the JavaScript engine, which also varies from browser to browser, just like the browser engine. When it comes to JavaScript, the way it is handled by the browser engine is through a hybrid approach called JIT, just-in-time completion. JIT stands for just-in-time completion, meaning that the completion is done during the execution of the code, rather than ahead of time like in compiled languages such as C. This approach combines the best of both worlds of interpretation and compilation. The JavaScript engine analyzes the code as it is executed and compiles the frequently used part of the code into machine code for fast execution. This makes the JavaScript faster and more efficient, which is crucial for web development where speed and performance are key. It's finally time to render a page. The browser uses the DOM tree and CSS object model to render the page. The first step is to construct the render tree. The render tree is a subset of DOM tree that contains only the elements that are visible on the page. The next step is to lay out the render tree. This is done by calculating the exact size and the position of each element in the render tree. This step happens every time we change something in the DOM that affects the layout of the page, even partially. Example of situation when the position of element are recalculated are adding or deleted element from the DOM, resizing the browser window, changing the width, height, and position of an element. Finally, the browser decides which nodes need to be visible and calculates their position in the viewport. It's time to paint them on the screen. This phase is also known as rasterization phase, where the browser converts each element calculated in the layout phase to actually pixel on the screen. Just like layout phase, this phase happens every time we change the appearance of an element in the DOM, even partially. Example of situation when the position of the element are relocated are changing the outline of an element, changing the opacity or visibility of the element, changing the background or color of an element. So that's the complete process of how a web page is rendered in a browser. The final step is compositing, which is done by the browser to optimize the rendering process. Compositing involves separate parts of the page into layers, painting them separately, and then compositing them as a page in a separate thread called a compositor thread. This ensures that the content is rendered correctly and is in the right order. It is important to note that the DOM updates, specifically layout and paint, are expensive operations that can significantly impact the performance of low-end devices. Therefore, it is essential to minimize the number of times they are triggered. And that's it. We have covered the complete process of rendering a page on a browser. So this is pretty much it for the video. I hope you did understood how the browser works under the hood. So have a pleasant day. Bye for now, and I will see you in the next video. Don't forget to subscribe to my channel to see some awesome content like this. Have a pleasant day. Bye for now, and I will see you next time.